In this video, you're going to learn how to be able to estimate the population mean or find the confidence interval for a population mean given a sample size. Since we're taking a sample, we do not know the population standard deviation. We are only using the sample standard deviation. Therefore, we're going to use the t-table, and we're going to use a particular formula on the Excel spreadsheet in order to be able to calculate the interval on which the population mean will be found. So for our first question, we want to be able to estimate the average miles per gallon you would get on a Ford Mustang. We have a simple random sample of 40 2007 Ford Mustangs. We calculated that the mean or the average gas mileage was 20 miles per gallon, and the sample standard deviation is 1.5 miles per gallon. We would like to construct a 95% confidence interval for the population mean gas mileage of similar 2007 Ford Mustangs. Now notice the beta again is based on the sample mean and the sample standard deviation, so we're using the notation X bar and S. X bar for the sample mean, S for the sample standard deviation. We put down the sample size of 40 cars. The sample mean is 20 miles per gallon, and the sample standard deviation is 1.5 miles per gallon. We want to calculate a 95% confidence interval. In order to do that, we're going to use the formula Confidenct, and what we have to be able, since we're looking for the middle 95%, we want to find out what is the area both on the left-hand tail and the right-hand tail, and that is our alpha. So in order to calculate the alpha, to create a formula, we have 1 minus the 95%. Remember, we put down the equal sign. And therefore, 5% of the area is divided between the right-hand tail and the left-hand tail. Now what we want to get is the margin of error. Basically, we want to know how many miles per gallon less than the 20 and how many more miles greater than the 20 miles per gallon is the population mean. And that is our margin of error. Well, in order to do that, we go to our formulas. We go to more functions, we go to statistical, and we go to where it says Confidenct. The first thing we need is the alpha, which we have already calculated. The second window, we need the sample standard deviation, which is the 1.5. And we need the sample size because the computer is going to calculate the standard deviation for all groups of size 40. Notice that the formula will have its result in 2 places on our template. And this tells us we're approximately 0.48 of a mile above and below the 20 miles per gallon. Well, in order to get the confidence interval for the population mean, we have to calculate both the lower bound and the upper bound. And the lower bound is going to be equal to our sample mean, which is 20 miles per gallon, minus the margin of error. And the upper bound is going to be the 20 equals the 20 miles per gallon plus the margin of error. I'm going to round that to the nearest hundredth, so therefore we have 19 52/100 of a mile is the lower bound, and 20 48/100 of a mile would be the upper bound. This tells us that the population mean is located somewhere on the interval between 19 52/100 of a mile up to 20 48/100 of a mile. So when we look at the sticker on these 2007 Ford Mustangs, there will be a number someplace on this interval that tells us that we are 95% confident that the population mean number of miles per gallon for a Ford Mustang is between these 2 values. Now let's go to a savings account problem. A local bank wants information about the average saving account balances of its customers. They took a random sample of 15 accounts and found the average balance was $686.75 with a sample standard deviation of $256.20. Well, with this information in mind, we again want to be able to calculate the average for all of the savings account in that particular bank. So in order to do that, again, we put down the 15 savings accounts from our sample, and we're told that the account balance is approximately normally distributed. Otherwise, we cannot use this formula. We have the calculated average of the 15 accounts is the $686.75. We have the sample standard deviation, which is $256.20. And now we want to calculate a 98% confidence interval for the true mean. Again, the first thing we have to be able to determine is what area under the curve is not included in the confidence interval. Since we're looking at the middle 98%, we have equals 1 minus the 98%. So we have 2%, 1% on the right tail and 1% on the left tail. Now we want to be able to determine the margin of error. To determine the margin of error, which means how much less and how much more will the population mean be from the sample mean. So again, we go to our formulas. And this time we can use recently used because we just used it. And we put down our alpha, which is 2%. The sample standard deviation, which is $256.20. And the sample size is 15 accounts. That tells us that I'm going to change this to money, that we are looking at $173.61 either above or below the sample mean. So again, we have to calculate now the lower bound and the upper bound of the confidence interval. The lower bound is equal to the sample mean minus the margin of error. The upper bound is equal to, and I'm going to get the equal sign there, the sample mean plus the margin of error. And I think I just clicked the wrong number. Yes, I did. Plus the margin of error, which is the $173.61, which tells us that when we look at all of the accounts, on average, we should have anywhere, the population mean should be anywhere from $513.14 up to, and I'm going to put a dollar sign here, $860.36. Now that is a very wide range of numbers, and because the wider the confidence interval, the wider the margin of error, and we can say that we are 98% confident that the population mean mu is located on the interval between $513.14 and $860.36.